So one of the first skills that you need to master really for organic chemistry is learning how to name the chemicals, and for this there is help at hand, and it comes in the form of this, which is an enormous book by the International Union of Pure and Applied Chemistry, which has some rules for naming things, and it really is a beast. So we're going to start with this one. The carbon atoms represented on this molecule by the points, and we show the bonds, and the hydrogen atoms are not shown, just to simplify the molecule. This is skeletal formula of a molecule, and to work out what this is called, we're going to say, right, 1, 2, 3, 4, 5 carbon atoms, and if we want a molecule with 5 carbon atoms, we use the word pent. So something with five of anything, we use the prefix pent, and because this is just a carbon chain with hydrogens, it belongs to the alkane family, and we replace that with pentane. So there are various different prefixes that you'll need to know. We'll start with 1, would be meth or meth, 2, eth, 3, prop, 4, bute, 5 is pentane, and then actually you could just carry on with the names of the shapes. Basically, if you think of a shape and think how many sides has it got, and you use the same word or the same prefix as the shape for the letters. So a pentagon would have 5 sides, so a 5 carbon chain is a pentane. If you had a hexagon, has 6 sides, you have hexane. So hept would be 7, oct would be 8, non would be 9, dec would be 10, and if I look at my IUPAC book, there's a table there of all the prefixes, which goes up to 9,000. Yes, they have a name for something with 9,000 carbon atoms in. It's a system which is very easy to learn, but you do have to just go away and learn it. So meth, eth, prop, and bute. So 5 for pent. 7 for hept, 8 is oct, 9 is non, 10 is dec. So we have all these prefixes that we can use, and if we put ane on the end, we mean it's an alkane, as in it's just carbon and hydrogen atoms fully saturated. So pentane looks like that, but we can get a bit more complicated than that, because actually not all organic chemicals have a straight chain of carbon atoms like this does. We can actually put carbon atoms on the side. So if I put a methyl group, that is a methyl group, so meth, 1 carbon, it's got 1 carbon, it's a group with 1 carbon. So we put a methyl group on that position. We say, right, okay, well the position that the methyl group is 2, and the group that we've put on it has 1 carbon, so we call it 2-methyl pentane. This is another molecule. Let's apply the same rules, but just to highlight something which examiners quite often do, is this molecule is a little bit of a trick question, because it's tempting to go, right, 1, 2, 3, 4, 5, 6, that's hexane, but actually there are different ways that you could do this. Look, 1, 2, 3, 4, 5, 6, 7. We can actually count a 7 carbon chain here. So let's look at that. We're going to go for the longest chain that has 7 carbon atoms, which means that we're dealing with some kind of heptane. So next we need to think, right, okay, well, we've obviously got another group coming off here. There's 1 carbon which means that we are dealing with some kind of methyl heptane. And so all we need to know is the number, where does that methyl group happen, because it could happen here, it could happen here, it could happen here. Where is it? Well, it's on this one here, and that is 1, 2, 3, 4, 5, 6, 7. So it's the third carbon along from that way. So we're going to call it 3-methyl heptane. Now, why did I start counting at this end? Well, if we start counting at this end, 1, 2, 3, 4, 5, 6, 7. If we called this 5-methyl heptane, that would be wrong, because what we're doing is we're going for the lowest number, and 5 is higher than 3. So we're going for the lowest number for our methyl group. It's not just organic groups that we can add, though. We can actually add other groups as well. Here's an example. We're going to find, again, the longest carbon atom chain. There it is. 1, 2, 3, 4, 5 carbons. So we know we're dealing with some kind of pentane. We're going to say, right, there's a functional group hanging off here, and it's a bromine atom, and the prefix for that is bromo. So this is some sort of bromopentane, and we've got two ways of counting. We can go 1, 2, 3, 4, 5, or we can go 1, 2, 3, 4, 5. 1 is lower than 5, so it's going to be 1 bromopentane. We can have two similar or different groups on the same carbon chain. So have a look at this one. We're going to do exactly the same again. The longest carbon chain is here. 1, 2, 3, 4, 5, 6 carbons. Therefore it's some kind of hexane. And this time we have a chlorine atom there. And we have a chlorine atom there. And 1, 2, 3, 4, 5, 6, or 1, 2, 3. So we're going to go with 1, 2, 3 because 3 is lower than 4. 1, 2, 3. So this time, because we have two chlorine atoms together, okay, they could be in any position, but because we have two chlorine groups to deal with, because we've got two chlorines in total, we're going to call this dichlorohexane. And because both of them are on the 3 position, we're going to put a 3, a comma, a 3, and then a hyphen. We have dichlorohexane. The comma there is important because if we had 33 dichlorohexane, that wouldn't make sense. And the hyphen there is a convention. If you have letters and numbers, you always put a hyphen in between, and sometimes there are letters which behave like numbers and tell us where on a molecule something is, and we use the hyphen to show that that's a position rather than an atom as well. Okay, so positions like numbers have a hyphen in between the number and the letter, and commas between all the different positions. So 3,3 dichlorohexane. So let's have a look at this one. We're going to do exactly the same as we did before. We're going to look down here and we're going to go, right, okay, well, what have we got, which is the longest carbon chain? So we'll start here. 1, 2, 3, that's obviously shorter. 4, obviously shorter. 5, 6, same length. 7, 8. Okay, so our longest carbon chain will go round there. That's going to be octane. So, what else do we have? Well, we have a 1 carbon group there and a 1 carbon group there, which gives us dimethyl, because there's 2 carbons. We know that we've got over here another group which has 2 carbons in it, and so methyl ethyl. And then that just leaves us with, well, where do we put these, and what number should they be? So let's have a count. 1, 2, 3, 4, so 3 and 4, 5, 6, 3, 4, 6, or 1, 2, 3, 4, 5, 6, so 3, 5, and 6. So the lowest combination of numbers we can have is starting here. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be based on octane. It's going to have alphabetically first E for ethyl, and then alphabetically second M for methyl groups. So we're going to put these two alphabetically, so E, M. And I know it's got a die on it, but we're ignoring that for the sake of it being working out the alphabetical order. So the bit which goes here then is 3, 4 hyphen dimethyl. Squeeze it in. There it is. Now before that, we're separating the letters and numbers with another hyphen, because I'm going to put an ethyl group in. And the ethyl is on the 6th position. It'll be 6 ethyl 3,4 dimethyl octane.